file handling in C++. So this concept exists in C programming as well. It is little different here in C++, since if you have not studied that before, also it is fine, because from this you can learn in C++ directly. So files in C. Why do we need to study file concept in C? Before we go into this theoretical concept, when you write a C program, or when you write any program you write, so you are writing a program using some tool, some IDE, you are writing some program and you are trying to execute it, you are trying to execute the program. It is asking you, one black console screen is coming sometimes, we call this as console, right. In this you are entering some input, maybe this is sorting of numbers, sorting of array numbers, so you are giving 10, 12, 11, 15 and something 9, like this you are giving some numbers, right. Once you execute this program, you wrote a program, you gave the input, you are able to see the output here itself, in the down, in the console only you are able to see the output. And once you close this console, again if you execute this program, again it will a new fresh screen will appear here, a new console will come here. It will ask you to enter the values, you will enter the values here and it will show you the output. You close it. Next time you want to execute this again with different inputs. So you will get again another screen, you are doing this. In this process, you see this one program which I wrote here, I am testing this program with multiple inputs. I am testing this program with multiple inputs and seeing whether it is working fine or not. That can be one case. Or for this program P1, I have multiple inputs to be given. Okay. So whatever input I gave during the first execution, it is lost. It is not saved anywhere. Is it saved anywhere? No. Why is it not saved anywhere? Because before little I go into the programming of declaring variables. Suppose if I declare a variable ABC, right, and if I write A equal to 10, B equal to 20 like this, when I write this statement int ABC, when I execute the program, in your whole RAM, okay, this is your RAM, your machines, you know about RAM very well, your machines have RAM. In RAM, some block, how much it requires, 4 bytes for each integer, there are 12 bytes. So 12 bytes of memory will be reserved in this RAM somewhere here, somewhere A here, some B here and some C here, anywhere, it is random, okay. So that's what when you use ampersand A, you will get the address, what is the location of this A in this whole RAM is given to us. So when I am writing int ABC like this, memory is allocated and when I put 10 here, 10 is stored here. Okay, as soon when you compile a program, you are writing return 0, right? At the end you are writing return 0. What is this return 0? It's a message to the operating system. It's a message to the operating system saying that my program is successfully executed. Whatever memory was allocated for this particular program, you can erase it. So you do some, it will take scanf statement or it will take input values 10 and 20 is stored. Then you are writing some cout statement and printing the value of C, assuming C equal to A plus B. You are writing cout of C. So when you write C equal to A plus B, 30 is stored here, and when you are printing, it is accessing the memory and printing the value. After that, there is a statement return 0. So because of this, this input is being erased. This completely gone. RAM became empty again. Again, once you second time when you compile this program, again some A here, some B here, some C may be here itself. Like this, it is allocated randomly at different locations. You give values of A and B, you do some operation, you print it. So values are filled and printing. When you again return 0, it will erase all those things, right? So in this process of this program which I wrote, this is a sorting program. When I am sorting the values, I am giving some input. That input it is taking, it is executing, giving the output. But what I gave before, first time when I executed the program, what input I gave, it is not stored anywhere. Second time what I am giving, it is also not stored anywhere. Okay, so that is the main purpose of files. In files, whatever input you are giving, whatever output you are getting, that will be captured using files concept in some files. Okay, In all these programs till now, whatever you have seen, if you are not using files, the problem it is, see, maybe you are practicing C++, you are practicing some concept in C++, you are writing some programs just to see, maybe in data structures linked list you are trying to execute just to see how it is working, that need not be saved. But when you write some big programs, when you write some lengthy programs which takes lot of inputs and which gives you so much of output, right, that you maybe that is one use case where input for the program is 100 lines and output is 1000 lines, for example. In that console you cannot see it, and that is one reason you can use files, because it will stay in your local memory. Okay, in local disk it will be saved. The second thing, that is not permanent, that input output is not permanent. So whatever I am giving as input, whatever output I am getting on the console, I want to capture them and store it in some file for my reference. It's a proof. This is one another example. Take another case why we need files. Okay, see, I have a file with me, maybe I have some CSV file with me, right? I have a CSV file with me. It contains all your roll numbers, your name, your subject wise marks. Okay, assume in a CSV file I have so much of data like this. Okay, your roll number is there, your name is there, and your marks M1, M2, M3, so on is there. Now my goal is to calculate percentage or GPA for all the students, assign them grade and calculate their GPA is the question task for me. So manually also we can do, but when we want to take help of system, what is your goal here? You will be writing one program. This program should read the records of students, first record, second record, third record. It should take the roll number one's data, calculate its percentage GPA and update it back in the same CSV file. Okay, so I want to do it using a program. I already have some 10 columns in that file. I want to add 3 more columns. Okay, so there are 1 lakh students here. So it is difficult for me to do manually also using the opening that CSV file. So what I am doing, I am giving this file, CSV file, as input to a program. This program we can write logic such that it can read all the values of the student. It can calculate the GPA, percentage, grade, whatever it want to calculate, and update the result back in the same sheet. Okay, this is also one use case of files. So for this reason also we can do this in C++ using files concept, right? So like this, one main reason is to store the data permanently. Whatever input you are giving, what output you got, if it is a mission critical program, you need to capture that input and output as well, because maybe that program gave output now, later it may not give the same output, it may misbehave, or you might have changed some program, you want to store it permanently always. So in that case you can use files in C++. Let's try to explore how we do this in files. Basically it's again if I am writing addition of 2 numbers programs. Okay, 2 numbers program. This is a simple program to understand how files work in C++. So I want to add 2 numbers, but I don't want to give those 2 numbers as input from the console, in the sense not through cin. I don't want to give through cin. Okay, so you can create a file, you can create a text file, let it be abc.txt. You can create a text file, you can put 2 values, 10, you can put comma 20 or 10 space 20 or 10 and 20 in 2 lines. These are different ways you can give the input. So we will take one case here. So I gave here 2 numbers, 10 and 20. Right. So when you write a program using files, you want to read it from the file. So we have some mechanism here where I can read this file, I can open this file, read the content, that is, and copy that content into 2 variables A and B, then do the operation C equal to A plus B, write the content back in the file, So here you can put 30 here like this. Okay, so what is happening in this case, whatever input I gave and what output I got, it is being stored in my file, and this is permanent. Okay, why? Because I am not declaring any variables. My variables are not stored in the RAM. They are stored in the secondary memory. They are not stored in the RAM. If I declare int or char or string, then they are stored in my RAM. Okay, so this is the simple understanding. You are going to use files for reading input and for displaying the output also. You want to put something in the file, you can put it there. You want to get some content from the file, you can take it. So there exists a file abc.txt. Okay, if there exists a files like this abc.txt, you want to write some input in this and save it, you can write it here. Or this file exists, you want to read some content, you can read the content from this file. For this we have so many inbuilt functions in this C++ which will help us to create a file like this, write content into this, read content, delete some content, play with this content of the file. This is possible using files concept. Okay, so this is basic understanding of why we need to study files, or what is the purpose of files in any programming language. It is available in C as well as in C++, in other programming language as well, right? So generally we do following operations when we play with files in C++. Naming a file, you have to give some name to the file, open the file, write data, read data and close. Okay, so these are basic steps. Let us try to explore about files. Before we enter into files, we need to study more about streams in C++. If you remember, when we studied about the streams in C++ in the beginning lessons, we studied about one very popular class, that is IOStream class, right? IOStream class. And also we studied there are two streams, there is iStream and there is OStream. These two are the derived classes of this parent class IOStream. In all our programs in C++, we are writing always this #include IOStream. Why? Because this is a kind of a header file. Okay, it's a header file. Again, it's a class. In C++, we call it as a class. It's a header file. In our general programming understanding, it is a header file. In this header file, we use so many functions like cin, cout. Right, these basic functions cin, cout are defined in two functions. So cin is defined in iStream and cout is defined in OStream. It is very clear, no? Input stream, output stream. So instead of including two header files, iStream and OStream, we are simply including in all our programs IOStream. It means both input and output streams. This logic of cin, logic of cout is defined in this IOStream. This is a parent class. Okay, it has two child classes or subclasses, iStream and OStream, right? So we have studied only about two things. IOStream is one thing, IOStream. It has two sub functions, iStream and OStream. But we are not specifically always writing iStream, OStream, we are writing IOStream. Same way, for files we have FStream class. For file, we have FStream as a class, or indirectly I will say as a header file. So there exists one header file, FStream. Okay, it also has two separate things. One is IFStream, other is OFStream. Okay, so we have to include this header file also. FStream header file we have to include. Why we have to include? If you want to do open a file, write some content into that, or already there exists a file, you want to read some content from the file. It means writing into the file, reading from the file. Okay, so you are doing some input output operation here. So those functions which help us in performing input and output functions in files, we have to include FStream. They are available in FStream. Actually, they are available in IFStream and OFStream, but we generalize and use this only function FStream as a common one instead of writing two separate header files. Okay, so what are those stream classes in C++? Let us see. Like this IOStream, FStream, what all things do we have? Let us try to explore them. So streams. What is actually a stream in C++? What is called a string? See, I am writing a program of addition of two numbers. Okay, normally I am writing it using cin, cout, you are reading those. Okay, using cin and cout, you are reading and writing those. So when you write a program with cin and cout statements, you are executing the program. It is asking you to enter some values. So you are giving values as 10 and 20. Right, this is the input, and in the output screen on the same console it is displaying 30. This is the output. So stream, the word stream here in C++ means a sequence of bytes, sequence of data, right. So this 1020 is called stream, this 30 is called stream. Okay, stream means the flow of data, a sequence of data. So 1020 is stream, 30 is also called as stream. So let's see the definition here. We give input to the executing program, and the execution program gives back the output to us. When you are executing a program, you give the input and the program will give back the output to you, right. The sequence of bytes given as input to the executing program and the sequence of bytes that comes as output from the program are called as stream. Okay, the sequence of input which you are giving as input and output which you are getting is called as stream, right. This is called as stream. So in other words, streams are nothing but the flow of data in sequence. So that text which you are entering on the console, in the black console screen, whatever text you are entering, the input and the output, that is called stream. To manage this stream, we have some stream classes. To manage this stream, that is this input data, we have some stream classes. One among them is IO stream. One among them is IO stream. Its use is to manage this data, this stream. To read a stream, I have some function in IO stream. To read an input, that's what stream is again. Stream can be input. So to read a stream, I have to use IO stream. To display some stream on the output screen, I have to use IO stream. So this is the basic things about stream in C++, and the input output operations between executing program and the device like keyboard monitor is called console IO operation. Console IO, that's what I am saying. We are talking always about this console. I say this black screen is called console. Once you execute a program, the black screen where you are seeing the output is called console. Console takes some streams and gives some streams, that is some sequence of data, right. So the interaction, the input output operation between the executing program and the input devices and output devices is called console IO operation. In the same way, the input and output operation between the executing program and files is called disk IO operation. Disk IO operation means secondary storage, that disk, you have hard disk, right. In that hard disk, you are creating a file, in that you are storing. So playing with that particular file and this program, that is referred to as disk IO operations. Okay, so like IO stream, C++ also has so many file handling methods. Okay, these include IF stream, OF stream and F stream. So you have to include F stream header file when you are writing programs with stream. Let us understand what are those streams in C++. So the first one under file handling scheme, again this is a collection of different types of streams in the entire C++. First one is IOS. IOS stands for input output stream. IOS stands for input output streams. Okay, this is the base class for all the other subclasses. We will see what are those subclasses. This class contains the necessary facilities that are used by all derived classes. Okay, so this we have to study at the end only about IOS. Let us see the I stream. So I already told you, IO stream is the parent class. It has two classes, I stream and O stream. So what is the use of I stream? I stream stands for input stream. I stream stands for input stream. This is the derived class from IOS. So there is a class IO stream class exists. In that, one among the class is I stream. What is this IOS? IOS stands for IO stream class. The one which we are writing as header file, no, it has IO stream, I stream. So this class handles the input stream. And which operator we use here? Extraction operator. Right or not? See, we always write like this, no? C in of A. What is this? This operator is called extraction operator. Okay. What is the use of this? It will take this whatever value the user is giving, that stream is copied into this A, right? C in of A, whatever stream in that console, whatever input the user is giving, that is copied into A. That if a user is giving 10, 10 is called stream because we are playing something with that data that is stored in A. So we use extraction operator, but we are not dealing this IO. We don't specifically always use iStream while programming. We will defaultly use IO stream only. Why unnecessary to include two files? But these are different classes which we should study. Second one is OStream. This is again, we know OStream is again part of IOStream. IOStream has another function or another class called OStream. Okay, so it takes care about the output. So which operator we use here? We use insertion operator. That's what, no, you write like this, cout, and you give some here hello, right? What is this? This means it will display whatever content you write here, it will be displayed on the console. So this is insertion operator. For that, this insertion operator is available in OStream class. Okay, again we always include IOStream by default instead of including iStream and OStream classes separately. Then comes the actual one which we need to know about for this concept, that is IFstream. There is something called OFstream, and for together there is a parent class called Fstream. So whenever you want to deal with input operations, you have to use IFstream. Whenever you want to deal with the output operations, you have to use the OFstream. Okay, so that's what Ifstream. This class provides input operations. Okay, it contains open function. There is a function open which belongs to this class IFstream. Okay, there exists a open function which belongs to IFstream. It is same as your cin function, Okay, there are other functions like get line, read. We will see this in due course once we proceed with the other concepts. So we have studied about IFstream. Same way we have OFstream. This is for output. Okay, this is for output. So this IFstream will put in input mode. This OFstream will put in output mode. So these are two kinds of streams for files specially. Then the third one is Fstream. It is nothing but the generalization of both IFstream and OFstream. Okay, these things when we see practicality, when we write a program and execute, you will understand it much better how and where we are using these streams. But I think you can easily relate it with the IOStream class, which has functions like cin and cout. Similarly, there is another function Fstream class, which has some functions for opening and for reading and writing. Actually, it's used for reading and writing. We use this Fstream class. Okay, so these are few stream classes generally in C++. Okay, so summarize. Now, since we are studying about files concept, in files which we will be using three things: OFstream to write on files, IFstream to read from the files, okay, and Fstream to do both. So you can use either OFstream or IFstream or simply use Fstream. Okay, be very careful here. One very important point and the confusing point here is that, see, OFstream, there I am saying OStream in IOStream, right? In IOStream class there is OStream. What is this used for? This is for cout with insertion operator. What is the job of this OStream class? It is to display, take the content from the memory, display on the screen. Okay, again I will repeat. When you are writing cout and A, it means A contains some value 10 already. Okay, so cout is used for take content from memory. Okay, from memory, display it on screen. That is the job of cout or OStream class. True. What about same thing for scene? Scene from the console, from the screen, take that value, store into the memory. So cout is helping me to take something from the memory and put it on the screen. Scene is helping me to take something from the screen on that output screen and put it inside the memory. So again I will repeat, cout is taking from the memory and putting outside, but that is O stream. But OF stream meaning is to write on files, means take the content from the screen, put it onto the files. Okay, take the content from the screen, put it onto the files. Actually that meaning is matching with scene, no? That is different. Here file stream, it is little reverse. Okay, right? So O stream class generally takes from the memory, displays on the screen. OF stream from the screen takes the content, puts inside the file. Same way if stream. IF stream is used to read from the file. IF stream is to read the content from the file. OF stream is used to write contents onto the file. Right? Again we have F stream class which does both the job. Whether you use if stream or OF stream or F stream, anything will work fine here. Okay, this is one small table here which will nicely explain you. So there is one iOS class, a base class is iOS. Okay, in that there is one function IO stream. Again, it's a kind of a base class, and then derived class is IO stream. See here, IO stream. It contains two derived classes, iStream and OStream. And what is the use of this iStream, OStream? Cin and Cout. Same way we have another class called FStream. So in iOS you have IOStream as a class, you have FStream as a class. In IOStream you have two, iStream and OStream. In FStream you have OFstream and IFstream. That is this just one diagram which tells us these stream classes in C++. Okay, there is a base iOS, it has two things, IOStream and FStream. IOStream has iStream, OStream, FStream has OFstream, IFstream. Same way you have another one, third one, that is SStream. Okay, SStream. So this is used for strings. We very rarely use this because we have so many string handling functions which can help us. In some advanced concepts of C++, we will be exploring this SStream. Okay, this is for taking input and putting output on the screens with strings, right? So this is about file streams in C++. One important point which I want to repeat here, OF stream. Its job is to take content from screen, put it in files. Okay, IF stream to read from the file and display on the screen. Okay, that one thing you have to remember, right? So yeah, we will go deeper into those things.